Okay, so our next lesson is just a continuation of our discussion of slope fields. And I really feel like these two lessons blend together pretty well. Maybe it would be beneficial to have this lesson or to listen to both notes before doing even the homework for 77, because this one just gives us some ideas or ways that we might consider how to sketch the slope fields more quickly. So one of them is what we discussed when we did the previous notes. And it says that when you're drawing a slope field for a function like dy dx equals 1 over x, where there's just an x and no y, where the derivative only depends on x, then all the slopes vertically are the same. So the x equals slopes would be the same, or in other words, it doesn't matter what you choose for y. When you're making your little chart here, then we could choose different values for x, and it makes no difference what we pick for y because y is not in our equation. And so then we can just plug those in, and our slopes will be the same vertically or up and down. So if I plug in -3, I get -1/3. -2 gives me -1/2. -1 gives me -1. 0 would be undefined. 1 would give me 1. 2 would give me 1/2. And so that gives me some slopes where I can sketch those in, and I can look and see those slopes on here. And this actually, if you look, has some marks on here. They're hard to see. So each one of these little slopes that they have drawn is not a unit. Like this doesn't represent 1, 2, 3. This is 1, 2, -1, -2. But anyway, what we're getting at, or the point that we have here, is that if we look vertically up and down, anywhere in this slope field, those slopes are the same. Vertically, slopes are the same. All right, and then the same is true. We didn't discuss this one, but it just makes sense that if our derivative only has y values, since the derivative only depends on y, then all the slopes are going to be the same horizontally. And so in this one, you know, if you're trying to pick some values when you get ready to sketch this slope field, then in this one, it's not going to matter what we choose for x. It'll only matter what we choose for y. And those values are the ones that will determine our derivative or our slopes, or our slope fields. So if I put in -2, I would get -1/4, -1, -1/2, 0, undefined, 1, 1/2, 2, 1/4. And again, you can see there's some little hash marks in here. Can't really see the ones going up and down this time, but that will help you in seeing those slopes that we just labeled. I have no idea why I did that up there. I just noticed. Oh well. So we get the idea here that if we have a derivative that is just dependent on x or just dependent on y, it's going to make drawing those slope fields a little bit easier. All right, so down here at the bottom, it has some pictures of various slope fields, and it wants us to try to match these equations with the slope fields. So here is a derivative where it only depends on y. And because it only depends on y, then that means that the horizontal slopes are going to be the same. So looking straight across, we want slopes to all be the same. And it looks like several of these have slopes the same horizontally. So let's keep going. If I look at this one, it has only y, but it has y twice, right? Same thing down here. We only have y, but we have it twice. And if I were to think of it this way, if I were going to just solve this equation, solve for y, I would set this portion equal to 0 and this portion equal to 0. And there are two different values of y that I would get for an answer. I would have two solutions to that problem where y would be 0, or where the function would be 0. And so those numbers, those values of y that give me a 0 for a solution, since there's two of them, there's two solutions here and down there, then I probably need to look for places. Look right here, there's a 0 slope for y. Looks like on the axis itself. Over here, here's a 0 slope. Here's a 0 slope. And this one, which also had all the same horizontal slopes, there's only one 0 slope. So these two pictures are going to go with these two equations. This graph has to be, this one only has one 0 slope. So this one has to be D. All right, so now to determine which one is which as far as A and B go, which one goes with which. Well, these values, the 0.06 y set equal to 0, where you get y equals 0, that's going to be the one that's here on the x-axis. When I set these equal to 0, I'd have y, negative y over 100 equals negative 1. I'd multiply by negative 100. Here, I would multiply by 150. And so this one's going to have a higher slope. So the higher slope, the higher value, is graph A, and the lower one is graph B. Now that leaves us with graph C to go with this equation, and this equation has x and y. So the slopes are not the same horizontally, nor are they the same vertically, because it depends on x and y. So this one would be C. All right, now this next page of these notes leads us into the next lesson. And I told you guys that we were going to be learning how to find solutions for differential equations. And so this is the beginning of that. We're going to figure out how we can separate this thing so that we can integrate it, because we know we can't integrate it with y's and x's together. So all we need to do is multiply both sides by dx. So we get dy equals sine of x plus 2 dx. Well, now all of my y's are on the left and all my x's are on the right, and I can integrate. And I know the integral of dy, or 1, understood to be 1 dy, would just be a y. And I know the integral of sine is negative cosine. The integral of 2 would be 2x. So I have negative cosine x plus 2x plus c. So that's my equation. And then it wants us to find the particular equation that goes through the point 3,5. So when x is 3, y is 5, I'm going to plug that in. And we can't really solve that without a calculator. I'm going to go ahead and just tell you, if you type all this stuff into the calculator and move it all over, c equals negative 1.99. You're going to need a calculator for that. And be sure you're in radians when you plug that in. And so if c is negative 1.99, then my equation would be y equals negative cosine x plus 2x minus 1.99. Now, that is solving a differential equation, and our entire lesson for the next lesson, 79, is going to be on solving differential equations. So we're going to have a lot more of that. But for today, they're pretty simple. You just need to multiply by the dx, and then you can integrate. The y's would be on one side, the x's on the other.